Hello viewers, welcome to the eMath learning platform once again. I am going to take you through the continuation of three-dimensional geometry, and we are specifically going to develop on the right pyramid right from the introduction that we had in the first tutorial. Now we are going to look at more examples. And question 1 says, in the figure below, ABCDH is a right pyramid on a square base ABCD of side 5 meters. Each slanting edge is 5 meters. This is our figure that we have been describing. And what are the questions? Calculate the part A, the height of the pyramid, correct to 2 decimal places. Part B, the angle between HBC and the base. And part C, the volume of the pyramid, correct to 1 decimal place. Let's look at the solution for this. Now, with part A, I want to specifically talk about part A first. If we are to find the height of the pyramid, correct to 2 decimal places, we are going to take any of the 4 right-angled triangles, which we said earlier that could either be HOC or H or A, or we can also take HOD, or we can take HOB. But remember, all of them will be forming an angle of 90 degrees at point O. Now, for my case, I'm going to consider HOC as my best triangle. That means I will have a 90 degree at point O. But remember, when I do that, it means I should be knowing the length OC. But to get the length OC, we have to first look for the length AC, the whole of this length here, which is the diagonal. And after getting it, we simply divide by 2 because this point O is the midpoint of AC. So that is what we're going to first begin by doing. So we have to first find the length of one of the diagonals, e.g. we are going to talk about diagonal AC. How do we get the length of AC? Now we are going to draw our base. Remember, it is a square base. It is a square base given by A, B, C, D. But our AC that we're interested in is one of the diagonals. And remember, AB is 5 meters and BC is 5 meters because we have a square base. So to get Y, the value of Y which represents the length of AC, we simply use triangle ABC, which is a right angle triangle, and therefore we shall employ Pythagoras Theorem. So how do we apply Pythagoras Theorem? We shall simply say y squared is equals to 5 squared plus 5 squared, and that will be our first step. And that, if you square 5 and square 5, you'll get 25 plus 25. And if you add 25 plus 25, you'll get 50. And because we want the value of y, we simply remove the square by taking a square root on both sides. So when you take a square root on both sides, you will come up with y as 7.0711 meters. At this level, I'm going to work with 4 decimal places first, because remember, at the end of it all, we shall round off the height to 2 decimal places. So to make sure the degree of accuracy is kind of high, you first work with the number of decimal places more than the number they want you to write it in. So now that we have got the value of y, what do? I now go back and now say, considering triangle HOC, which we said we would actually look at, and this is our triangle. The 90 degree is at point O, and this is point C, this is point H. Where have I got this triangle from? You can just go back to our original diagram and we look at it. So it is going to be this H or C. I gave you other alternatives that you can take, but our 90 is at O. Now that we have got AC, length AC is already gotten, we simply divide it by 2 to get the length OC, and that is what we're going to do. So when you do that, you're going to realize that we shall have 3.53555 meters. How have I got it? By simply dividing this length of AC by 2. Then remember, your HC is one of the slant edges, and so it has its length given as 5 meters in the question. Remember, all the slant edges have equal length. So now that I have this triangle, I can simply use Pythagoras Theorem to look for the value of h. So h squared plus 3.5355 squared will be equal to 5 squared. That will be my first step. Then after that, I simply square these constants. I'll get 12.50011 equals to 25. Then I simply take this to the right hand side such that I remain with h squared alone, giving us 25 minus 12.50011. Then from this point, since we're looking for the value of h, you take the square root on both sides. So when you take the square root on both sides, you will get 3.5355 meters. But remember, the instruction was the answer should be to 2 decimal places. So what does it mean? It means h will be 3.54 meters to 2 decimal places. So that answers our first part of the question, which wanted the height of the pyramid. And we are saying the height of the pyramid is 3.54 meters to 2 decimal places. Let's look at part B of the question. Now, part B was interested in the angle formed between the plane HBC and the base. Now, we said in the first tutorial of three-dimensional geometry that when you want to get the angle between two planes, because HBC is a plane, you simply look at the point, you draw a line of symmetry for that plane. You draw a line of symmetry. Now, if you look at this red line here, it is our line of symmetry of this plane HBC. Then after that, you now look at the base. Our base, remember, is A, B, C, D. So from the point we have stopped in, this very point here, point E, you also think of how to draw the line of symmetry of the base. So the line of symmetry will be this red line that you see, which would continue up the extreme end here of the base. But remember, you're interested in only coming up with the right angle triangle. So that is why I simply took only this distance from point E to the center, which is our O in this case. Now the angle that you want is going to be the angle between the two lines of symmetry. And which angle will be this angle here? So when you do so, you come up with this triangle here where we have HOE. HOE. But how do you get length OE? Remember, length OE is going to be a half of this complete length here. So getting a half of 5 will give you 2.5. Then the height, you already got it as 3.5355. Now, why haven't I used 3.54? We are using 3.5355 because it will increase our level of accuracy. But if you use 3.54, the level of accuracy will be compromised. So from this point, we can simply use our soccer tower, whereby we say tan of theta is equals to the opposite out of the adjacent. And from that point, our theta will be the tan inverse of all this. And that will be our next step. Then you simply press the tan inverse of 3.5355 out of 2.5 from your calculator. When you do so, you will come up with 54.74 degrees and write it to at least 2 decimal places. Then the next question was saying we get the volume of the pyramid. Like earlier we had said in the first tutorial, we said volume of a pyramid is given by a third base area times height. So you get the base area, which is going to be the area of the base. If this is our base having a square base, then it is going to be 5 by 5. Then our height is the value that we found out as 3.5355. So that is what we are going to substitute here. Then you press your calculator correctly, you will be able to come up with 29.4625 cubic meters. But remember, the instruction was to 1 decimal place. So you simply round it off to 1 decimal place, giving us approximately 29.5 cubic meters. With this comprehensive example, which adds on to the first one that we had in the first tutorial, we shall now say you can try out an exercise that will come right in the next page. So this is our exercise. I've quoted for you the answers. This is question 1. Answers for part A, B are all given. Then question 2 also has all the answers given. Question 3 also has all the answers given. Now, our next tutorial will simply contain cuboids and cubes. Don't dare miss. Remember to visit our YouTube channel and make sure you subscribe to continue receiving updates for continuous learning. Thank you so much, and may God bless you.